Welcome GibbsCAM users. Today's video is going to be class number 3 in our series of 2025 GibbsCAM videos. Today we're going to show you a little bit about solids in a 3-axis vertical mill. Basically, we're going to show you what we did on class number 2, but this time we're going to be doing the same thing but with solid models. So let's get started. First thing we want to do, of course, go to File. Even though we're going to import a solid model, we still want to go to File and click on New, not open the solid yet. So click on New, find the folder where you want to keep your file, and then give it a name. I'm going to call it 3-axis solid, so save that. And of course it's going to open up a blank screen for you. Now we're going to import the solid model. Now the solid model may or may not be in the correct orientation which you want, because if you're working on different parts for, say, aircraft and automotive, sometimes the origin will be at the nose of the plane or tail or wherever the original designer decided to create the main origin, and then they put the parts on that particular project, wherever it may be, whether it's be a plane or a car or whatever. So the origin may not be where you want it. So we're first going to import our solid model. So go to File and Import and find the folder which has your solid model. And I will include this model in the under the descriptions. You can download this model to start with. So here I have it. Let's just look at this drop-down menu. I have it set for all files, but you might have it set for, say, SolidWorks or something like that, and you may not see the file. So this file that I have attached that you can download is a Parasolid. So I'm going to go to Parasolid, and you'll see the file right there, Class 3, 3-axis milling solid. So just click on that and click on Open. Now it's going to open it up in your workspace there, as you can see, and it's not where you really want it to machine it. If I go to isometric view, you'll see it's kind of skewed both directions, kind of a compound angle. So the first thing we want to do, of course, is probably orient the part and get it flat to where we're working on a 3-axis vertical mill. And there's a couple ways to do that, but the easiest way is just to find a flat surface. It could be any flat surface. Even a little small surface is fine. Make sure you have face selection on so you can select different faces. And you want to select the top face here. Then while you're there, just right click on the yellow that you've selected. Go down to where it says Align Face to CS. Now what that's going to do is we already have our XY plane. As you can see here, if I open up my coordinate system, the standard 3-axis mill is an XY plane. So we want this surface to be parallel with this plane. So again, right click, go down to Align Face to CS, and you can see immediately it aligns to the face. If I go to top view, you'll see it's aligned to the face. If I just rotate around, you can see that flat surface is now perfectly aligned with that face. Now maybe you want to rotate it another direction. You can do that as well. If you have a flat surface, you can rotate it to another coordinate system, or you can manually just rotate it. So after we do that, let's just go to Modify and down to Shrink Wrap. And what Shrink Wrap does is it wraps material around the outer boundaries of the solid you just brought in. Now, of course, we're not going to purchase our aluminum stock right to size there. Of course, it's going to be bigger. But first thing I want to do is probably go to Top View, open up our document control, and you can see the size there by looking at the stock size and origin there. Now these are kind of, since the origin is not in the upper corner or anything else, and it's not symmetrical about the center, you can see these numbers are a little bit different. So the first thing I probably want to do is I'm going to move my origin up to the top left corner, then we'll add some material around there. So just go to Move Part Origin. You can copy these numbers if you want. So if you want to copy this number, you can just copy and paste and copy and paste and click on Do It. And you'll see our origin is now in the top left corner. And this is pretty much the stock that it says it needs to cut this part, but of course we want to add material to that and make it somewhat of an even number. Probably going to add about 1/8 of an inch to each side there. This is 0.392. We'll probably make this a even 5, or actually maybe not, probably let's try 4.5 and maybe minus 1/8 of an inch. That should give us some material around the outside there. This will be 4 5/8 material, and probably the same thing here. We'll add 1/8 of an inch there, and this one probably minus 4.5. That'll make it 4 5/8 square. You can see we do have material around the outside there. Now I might just move my origin up another 1/8 of an inch just to get on the corner there, so when we touch off our edge finder or probe, it'll be right at the corner of this part. So I'll just go minus 1/8 of an inch, and another 1/8 of an inch. And now we have our origin, top left corner, and this is our stock size here. And our 0 point is good, but we need to add material on there, so probably 20 thou. And again, just like our last part, we need to add material to it so we have something to hold in the vise. So I'm probably going to use 1¼ inch material. So with 20 thou off that, that'll be minus 1.230 material there. So now we have our stock. Everything pretty much ready to go here. Make sure you update your clearance. One thing that you want to be aware of is if you have your origin at the bottom here, we'll just show you this in case you bring in a solid model. Let me just show you what would happen if let's just put 0 in some of these, and minus, we'll say 2 inch. So we moved our origin down 2 inches there, and you can see Gibbs automatically adjusts for that here on our clearance. But now let's say you had clearance of 1/4 inch here, and your solid model came in, but the origin on the solid model was down below here. And then if you go to modify and move part origin back up to the top, and you could do that by holding the Alt key down, clicking on your top surface, clicking on do it, and you can see Gibbs subtracted that amount. So now you have a negative clearance of 1 3/4, and so that wouldn't be very good because your tool is going to wrap it to that minus 1 3/4 before it starts cutting. So always look at this number, especially if your Z was down below your part when you imported it in, and then you moved it to the top, it will subtract from here. So always look at this. Okay, you might not see it on the rendering. When you render it in Gibbs, if your tool starts outside the part, you may not catch that tool going way deep and then back up. If it was on the part, of course, you'd see it when it rapids down and in, but be careful actually making your part, so make sure your clearance is good there. Okay, next we want to aluminum alloys, same thing there. Everything there on this page looks good. We're programming in inches, of course. So always double check that as well, because some parts come in as millimeters, and basically all you need to do is change this to inches and then adjust your stock size from there. So on this part, we're still, let me close this, we're still going to be using geometry for some of this and maybe solids for more of it as well. And so let's just start extracting some geometry. So you can separate these into work groups if you want, or you can just name the main work group. We'll just call this milling. Make sure you click on actually where it says work group, otherwise it won't change. Okay, we'll just leave that work group there. Of course, you can make as many work groups as you would like, depending on what you want to do. We do that a lot on turning, not as much on milling, but you can create as many as you want. Make sure your coordinate system, you're on the XY plane. This isn't a 5-axis part or 4-axis part, just a standard 3-axis part. So let's start extracting some geometry. Now this part doesn't have a chamfer on it. We're going to put a chamfer on it anyway, just to break the edges, to kind of deburr it. So there's a couple ways you can pull geometry off this part. We'll show you the 3 or 4 different ways. First one is to make sure face selection is on, so you can select the different faces. So you can select this top face, and since it doesn't have a chamfer, it's going to go right to the edge. If it did have a chamfer on your solid, you could just go to the bottom and click there and extract it off there. But since this doesn't have a chamfer, we can go right to the top there, right click, go to extract edges, and usually you want a tolerance of 0 in there. What this means is if the hole is not perfectly round, Gibbs, and you have 0 in there, then you're not going to end up with a circle, you're going to end up with a spline. So sometimes you can put in a tolerance in there if you want, but I know these holes are good, so you could we'll just put a thou in there anyway. Now to double check to make sure everything is good, holes are actually holes because you can't drill a spline. You can drill a hole but not a spline. So the best way to check that is just hold the control down and press the L key, and that'll turn on labels. Gibbs labels everything here, so you can see C's are for circles, P's are for points. You can see the circle here says C6, so that tells me that is a circle, it's not a spline. If we had a spline, which we don't on this part, it would be a B, so it would be labeled with a B, letter B. But everything here looks good. These are all C's and L's for lines and P's for points, so you can do Control L to turn that back off if you don't want to see those. So that's one way to do it. Let me just hide the solid for a minute. And we'll just do Control A to select everything and delete it, and then turn our solid back on to make it visible. The next way is using the profiler here. You can click on the slice plane. You can see you have a number of different ones, but this one, slice plane, for this particular part would be just fine. So you could drag it off the edge. You can pull it down wherever you'd like. This is really nice if you have some undercuts and things like that, or different heights of shelves that you want to get to. So you can drag this wherever you want. You can also right click and say go to a certain depth. So if I said go -1/2 inch, it'll move it to that level right there, and you can pull the geometry off there. You can actually machine it just with this geometry here, but normally I like to extract the geometry, so you can click what geometry you want to extract, or you can actually right click and say select all profiles. And so if I did this, I could now extract the profile. But let's just bring this, let's go to the extract profile. Let's go profile depth. Let's go -0.0001. It can't be 0, because if you have 0 in there, and I'll show you here, it's not going to pull any geometry off. So you got to at least go a little bit below the surface. -0.000. We'll try 0.1. Even just a little bit will get you your geometry. So then you can extract the geometry there just by clicking on it, whatever you'd like to extract, or do all profiles. Then just right click and say extract profile again. Turn that off, and you can see there's your geometry that you selected to extract. Turn that off. Let's do Control A again and bring back our solid. So there's a couple ways. Another way, if you just want to get certain edges here, you can turn on what we call edge selection right here, visible edge selection. You can see it turns your part into a wireframe. And here you can select an edge, single edge. A lot of times you can just double click and it'll loop it around. It depends on what CAD program it used. Sometimes it'll jump down instead, so be careful when you double click, but most times you can double click and it'll loop clear around, or if you just want to get one single one, you can just do that, and again extract edges and that. So probably the easiest one for this part would just be to, again, click the top edge, right click, extract edges, click on do it, and there you have your geometry ready to go. So next we're going to bring up our tools. Open up our CAM and tools. You'll notice I don't have any tools in here. I'm just going to import the tools that we used from the previous part that we did on class number 2, so we don't have to recreate all the tools again. So basically, to do that, you can click anywhere in this list and just right click and go to Load Tools. Notice there's a Browse and a Set Folder. You can actually create a folder and set it to that folder. So you can create a folder for, say, all turning tools, all milling tools, or a particular tool list. If you have a horizontal, which some horizontals have a hive, and you could have 300 plus tools on there, you could just click on Set Folder and click on that particular machine, and it'll load all the tools up in your machine. So again, just right click, go to Load Tools. We'll click on Browse because I haven't set a folder. And there's your folder, there's your tool list that we did for class number 2. So just click on that, and always remember to make sure you preserve tool number. Make sure this is checked on. This is by default now. Didn't used to be, but it is now. And the reason why is if you have a blank spot in between tools and this is unchecked, it will move all the tools up. So that's not very good, especially for tool changers that have dedicated positions on there in the case of many horizontals. So you don't want to grab a tool and find out it was in the wrong pot. So make sure this is always selected. Then just click open. It's going to take a second, and then you'll see you'll have your tool list here. This is the same tool list we used for class number 2. You can always open these up and look at the tools if you need to from class number 2. But that'll be on the list as well. I'll put this tool list in this YouTube video as well, so you can always click on that to do it. And we're also going to basically steal the processes from class number 2, so we don't have to create all of them the same again, but we'll show you how this works with solid models because there will be a few differences here. So the first thing I want to do is, of course, face this off. So I'm going to go to process here, just right click and click on load process. Notice here's a browse and a set folder again. We're just going to go to browse, and you'll see I have my list here that I stole from the class number 2. This is all the processes, operations that we did on class number 1. So the first thing I want to do is click facing. So click on that. It's going to load the process up, and if you didn't have a tool in there, it would have already pulled that tool and put it in there. Just to show you how that works, let me just get rid of these. We'll just show you. So right click, go to load process and facing, and notice it created the process and also loaded the tool up. So you can do it both ways, but I normally like to just bring in the tool list. So we'll just do that again. Load the tool list. There we go. Now we're going to open up the process list. So we'll just click on empty a tile there and just right click on here, load process list, browse, and facing. So if I open up the facing, and this is good if you have similar parts to do, you can always open this process and change the speeds, feeds, depths, whatever you like. But if this worked for another part and you have another family of parts that's similar, or you like the feeds and speeds, how this worked, you can just load the process up and then change the your depths of cut, things like that as you need to. So let's just click on do it. And there's our first cut, just like we did on class number 2. Let's clear this out. So the next thing we want to do is cut the, I believe we cut the periphery next on the last class. So we'll show you that. Just right click and load the process. And we're going to be cutting the, going to do the volume mill OD this time. So we'll open that up, and that's going to open the process, and that's going to highlight the tool we use for that process. But the nice thing about volume mill, when you're working with a solid, you could have use stock on. Of course, we didn't change anything here from class number 2, and you can just click on the solid itself. Make sure face selection is off because you don't want to just select the face. You want to select the whole thing, and just click on do it. You can see now we have our periphery cut. Same thing we did with class number 2, other than we didn't have to make an air wall in here because we had a solid model to work with. Okay, so the next process we want to do, operation, is going to be probably, I believe we roughed out the cavity, so we'll clear this out. Right click, load process, browse, and we're going to click on large pocket first. We could probably do both pockets at the same time, but we'll just do them. Well, actually, no, because this uses a different end mill than the small pocket. So we'll just open that up. This time we're going to click on the inside of this pocket over here, so we can just do that one. We're going to open this up, and we're going to change one thing on here. We're going to click on ignore stock. If I do cavity only, it'll do both of them. We just want to do one here, so I'm going to click on ignore stock. Everything else there is the same. 3/4 deep. If you didn't know the depth, you could always highlight that, hold down the Alt key, and click on the bottom face that you want to get to. You can see it still says -3/4. If I put in 0 there just to show you again, Alt click the basement there, the floor, and there you go. Everything else there is good. Same thing we had before with the geometry. We're leaving some XR stock and Z stock. So just click on the bottom there, click on Do It, and now you have your tool path for the large pocket. Let's clear this out and let's bring in the next one. Let's do this time the small pocket, and we'll open that up, and we'll click on Ignore Stock again. Everything else there is the same, 3/4 deep, leave some stock. Click on the floor there and click on Do It, and we'll just have that cavity there. So let's see what we've done already, where we're at. So face, we'll speed this up here so it doesn't waste a lot of time. And when we did the cavities, we did, of course, helix, and we let Volumill choose how it wants to helix in. Speed that up there. And there we have our roughed out outside and the roughed cavities there. So next we want to finish the outside and finish the inside, so we'll clear this up. We'll right click and bring in the Finish Periphery. Okay, again, we'll click on the outside there, but we'll just click on one face there, just right click, go to Select Tangent Faces. That should get everything around the outside there. Looks good. And then click on Do It, and there's our outside of the part. Again, if you want to use geometry, since you extracted that, you could do that there and choose the direction, and if you want to go outside or not, that's up to you. So that finished the outside. Now we need to finish the inside, so I'm going to clear this out, right click, load the process, and we're going to finish the pockets. Okay, so we're going to click on both the pockets there, and we'll click on Do It. And there our pockets are finished. So if we render so far, we can see what we've done. And we'll slow this down. There's the outside. Of course, the inside. Large pocket with a 1/2" end mill. And 3/8 end mill to finish the small pocket. Okay, so next we want to, let's do some drilling here. So we'll just click in space to deselect everything, maybe select an empty tile to make that go away. And let's clear this out. Let's bring in Load Process Browse. We'll just do spot drill the 3/16 holes. Everything there is the same from class number 2. You can always open them up and look at it. Let's just choose the 3/16 holes. Now there's a number of ways you can choose holes. This is with geometry or solids. Of course, this is only a few holes here, so we're just going to manually pick them. Otherwise, you could go to Select Special, select all holes or different radiuses, or you can select a number of different ways you want to select holes. But let's just select the 3/16, and you could select either the inside or the geometry you extracted on there. Either way would work fine. Click those, and let's click on Do It. Now we have our spot drills. Clear this out, load the process. We're going to do the spot the 3/8 hole, and again just click on the hole, click on Do It. Now we need to go and drill the holes, so again load process. Now this time we want to drill the holes, and we'll just select the holes here. Make sure you don't select the 3/8 hole, and click on Do It. Now we want to do, of course, clear that and load the process and finish drilling the 3/8 hole. And now we have almost everything done. We'll just render this up to this point. There's our spot, drill, and our 3/8. Now the next thing we want to do, like I mentioned before, is chamfer the outside of this to kind of deburr it. Combination spot drill chamfer tool to do that. So let's clear this out. We'll just load that. I believe we loaded that process as well. So let's do the chamfers, and it's going to load up the process for that. So once we have this opened, we're going to change it a little bit. Under the offset little tab, Gibbs always goes by center line there, so let's just go offset. And let's just click on inside, click inside. So we want to do all inside. We want to cut these two basically at the same time. And we'll put in everything there. Everything looks pretty good there. So we're going to select both of these. And since Gibbs knows it's going to cut the inside, we can just click on do it. And now we have the chamfers for the inside. I'm going to keep the process. We're going to just modify the process. And go back to offset. Let's just do center line, back to center line again. And let's just choose the side and what direction. And we want to cut the outside, click on do it. So now let's render, let's take a look at that, see if we got everything okay. Slow that down and play. So there's our chamfer there, outside. And for the most part, this part is done. Now we need to add the vise in, and this time, of course, we have a solid to work with, so that'll make bringing in the vise a little bit easier. But first I'm going to close the cam and the tools so we don't accidentally delete something. Now since I'm bringing in a vise, I want to kind of work with a solid. Now there's not a flat surface on here to bring the jaws up to, and like on class number 2, we just kind of estimated there. But this time we're going to bring in a solid and actually put it in the correct positions. But first, what I want to do to make it easier, I'm just going to go to the solid modeling palette and click on the button here to create a solid. And we'll click on this button here. Where's my note popping up? There we go, cuboid. And just click on this button that says stock dimensions. So what that'll do is it's going to create a solid model of our actual stock that we created there. So there I have my stock, same size as we have in our document control. We'll just keep it as a stock for now, that's fine. We could turn it into a stock body, but Gibbs already knows the stock size, so that's fine. We could make it into stock or just leave it how it is. So now let's bring in our vise. So again, we're going to import, file, and click on import and import our vise again. Again, this is a parasolid, so make sure you select that. Click on open. And it's going to bring in our vise. And of course you can see the origin on the vise matches the origin on our part. So we need to change our course vise into a fixture. So make sure face selection is off, select the rear jaws and the main vise there. Right click anywhere on the yellow, click on show properties of selected because there's more than one, so you can see them up here. And let's change this to fixture display only. And most of the fixtures I like to have at 10,000ths. And that's good. Now you can see that it's a fixture, but it's still inside our part there. This jaw matches up just fine. Let's move our vise over a little bit. Let's just go to modify. Let's just translate it just like we did before. So I'm going to move it how about 3/4 of an inch. That pretty much looks pretty centered. Let's go to a side view again and select your vise. You don't want to move it any more in X, but you want to move it down at least an inch because our part's an inch long. I'm going to go minus 1. Let's see, I think we went 50 thou deep, so 1.1 will be just fine. Okay. Now we'll show you how to line this up, this jaw with the actual stock there. So make sure face selection is on again, so you can just select different faces there. Let's go to the plugins and let's do solids alignment. So what we want to do is align this jaw to the back solid model, which is our stock size. So first you want to click on the vise, the back of the back jaw of the vise, what you want to move, and then hold the control key down, select where you want to move it to, and then click this button here, which I don't know if it's going to pop up a note, but this aligns the jaws there. And there you go. You have that lined up correctly. Let's look at the rendering once more. Of course, our volume mill. Speed this up. Actually, I'm going to turn this off and click on, uncheck that, and click on this button that says stop before every tool. So we want to get through this a little bit faster, so we'll just speed that up there. Okay, that's what that tool did, the 1/2 inch end mill. Then the 3/8 end mill, you can see volume mill automatically does a helix for you, or you can do a ramp, it's either one. Okay, that is done. Okay, now we want to finish the outside and finish the inside there. That's with the same tool, 3/8. And the same thing with the cavity over there. Finish the floor, finish the sides. Now we change tools. We need to go to chamfer now. Actually, we're going to drill the holes. And 3/8 hole. Now if I look at my operation list there, my chamfer tool is tool number 5, which is the spot drill chamfer tool. So you can see I'm doing tool number 5 to spot. Then I'm going to use tool number 5 to do chamfers there. And we could maybe make this a little more efficient if we wanted to. Maybe we want to, let's just say we want to chamfer before we drill the holes. So it's easy to do in Gibbs, just to show you how you can modify things. So let's select the chamfers there, and let's put them before the drilling. So I could just move them up and put them right in the triangle there. Now if we render again, face, cut the OD, cut the one pocket there. Okay, finish the outside. This time, chamfer, chamfer, chamfer. Then use the same tool to spot drill, then drill. And of course, your part is finished. So just one way to do solids on here. That's just a simple way to bring in your solid model and kind of align it, get it ready to go, and then cut your part. So with the same tools we used on class number 2. So I'll put these models in the under the more in the description, so you can download these as you need to, and then practice on this part working with your first solid model. So thank you for watching.